I'm sitting here with Sir Isaac Newton, the famed math genius, to ask him a few questions about his most valuable contribution to science, his 3 laws of motion. Mr. Newton, thank you so much for joining me.
No, thank you.
So let's start with your first law of motion. How did you come upon it, and can you give me a brief description about it?
So my first law is that of inertia, or an object that is in motion desires to stay in motion unless a force is acted upon that object. So basically, if an object is stationary, it will stay still forever. But if an object is moving, that object will remain moving indefinitely at the same velocity. And so, I didn't actually come up with this law myself, but this man named Galileo, he came up with it. And he used it to explain the motion of planets, which, he used it to explain the motion of planets, and then I adapted it so as to explain the motion of everything. And that is how my first law came into existence. And now I'll have my assistant explain to you this better.
Let's look at this pool ball. It stays still since no force is applied to it. Now, a force is applied to it, and it begins to move. The same principle applies to an object that is moving. It will continue to move unless acted upon by an outside force. See, as the ball is pushed, it begins to move and continues to move. Now, according to Newton's first law, this ball should continue to move until acted upon by an outside force. So, it should move forever at the same speed, but that's not what happens here. So how can we explain this? The answer is friction. Friction is a force that resists motion. In this case, motion between 2 moving surfaces, the table and the ball. Friction on the pool table is low, but if we were to use the same ball on another surface, the effect of friction will be very different. See, on this thick carpet, the ball stops almost immediately. On this hard floor, the ball has very little friction, and therefore goes farther with the same push.
Thank you for explaining your first law. So let's move on to your second law. Can you explain that?
So my second law is that force is equivalent to mass times acceleration. Or in other words, acceleration is equivalent to force divided by mass. They're both the same thing, really. So, if you were to take a certain force and apply it to an object, it will have an acceleration. However, if you were to double that force, you would double the acceleration. And if you were to double the mass, you would halve the acceleration. My assistant will help give you an example of that.
To demonstrate this, here is one person pushing a car. You can see that the car moves slowly, since it is very heavy, and therefore resists motion. Now, if we had a second person, the car moves faster, since a greater force is now applied. This is because acceleration is dependent on mass and force. The mass is the same in both cases, however the force increases, and therefore the acceleration increases as well. Similarly, here are 2 balls of roughly the same size and shape. We will apply the same force to both, and see how each one accelerates. As you can see, the tennis ball has greater acceleration, and moves farther than the much heavier pool ball. This again shows that acceleration is dependent on mass and force. The force is the same, however, since the tennis ball is lighter, it travels much farther.
Thank you for the description about the second law. Let's move on to your third and final law. For many, this is the most challenging of them all. Can you give us a description about it?
So my third law is that for every action, there is an equal and opposite reaction. So if I were to have an action going in this direction, there will be an equal and opposite reaction going in this direction. It has the same force, however it's going the opposite direction, so it is equal and opposite. My assistant will help give an example.
So, as Newton said, for every action there is an equal and opposite reaction. Let's look at this pool ball again. As it is hit by the pool cue, it rapidly accelerates, then it hits the next pool ball and stops, while the other pool ball continues forward. This is because the white pool ball is moving, and when it hits the gray pool ball pushes it in the opposite direction exactly the same amount as the white ball pushes forward on it. Because of this, the motion of the white ball is completely stopped. Now, let's look at another example. This foam ball is thrown against the wall and exerts a force on the wall. Likewise, the wall exerts an equal and opposite force back on the foam ball, forcing it to move away from the wall. For our final experiment, let's look at the same foam ball, this time being held up by a board. The ball exerts a downward force on the board, and the board exerts an upward force on the ball, which is equal and opposite. Therefore, the ball does not either float above the board or fall through the board. Now, let's remove the force pushing up on the ball and see what happens. Now, when we place the ball in the same place, the board is no longer there to push upward, and therefore the ball falls to the ground.
Thank you for coming on the show today and explaining your 3 laws. I hope we see you again soon.
Thank you for having me on the show.